后台有不少粉丝表示想要听我来一段英文物理学单口相声，今天就给大家学一段讲费曼的路径积分，大家就当练练英语听力。The path integral formulation can be regarded as a philosophical interpretation of quantum process invented by Richard Feynman, one of the greatest physicists in the 20th century. It is shown to be equivalent to Heisenberg's matrix mechanics formulation of quantum mechanics. But the philosophical idea of path integral is easier for people to understand since it shows the connection between quantum world and the macroscopic classical world. The basic idea of path integral is like this. Suppose you throw a ball from some point A on the ground and the ball landed on another place B other than A. The trajectory of the ball in the air must be a parabolic line according to the second law of Newton. But if we switch to the quantum case, we throw an electron from point A on the ground. The electron experiences a gravitational potential, and thus we should describe the behavior of the electron using Schrödinger's equation. What will the trajectory of an electron be in this quantum mechanical case? Since we have the uncertainty principle, we can't have a specific trajectory of the electron. If we want to detect the electron during the quantum mechanical process, we can find the electron everywhere with different probabilities. Now here comes the path integral interpretation. Feynman said the electron will have all possible trajectories during the process, and all trajectories exist with different probabilities. The probability is proportional to the exponential of its minus action. Here by action, it is a quantity related to the energy of a certain path. Generally, the smaller the action, the larger the probability. Guess which paths have the largest probability? Of course, it is the parabolic line possess the smallest action and gives the largest probability. So for throwing an electron, the trajectory is not a line, it is a bunch of thread, but looks like a parabolic line, except it is the blurred line. This interpretation is a connection between quantum mechanics and classical mechanics. Now come back to the classical ball. It consists of trillions, protons, neutrons, and electrons. You throw a ball, all of the quantum particles follow the path integral formulation. If you want the ball goes apart from the classical trajectory, which is a parabolic line, you need trillions of particles to follow a path other than the one with the largest probability, then it is statistically extremely unlikely. So the macroscopic world is just a statistical most probable result of the quantum world. But talking to the mass of path integral formulation, it is not mathematically rigorous. Mathematicians have not proved the validity of the integration over infinite dimensions yet, although physicists have been using it for several decades. Mission accomplished. 讲完了，满意不？点个赞呗。